Hi everybody, here we are at 3-4 doing some operations with exponents. Let's remember a couple of concepts. If you remember when we had feet times feet and we multiplied that together, we got square feet. So this rule right here, this kind of demonstrates a little rule here that if you have an exponent and you're multiplying, or a unit times the same unit, you're going to get that unit to the second power. Well, what happens if we have it times the same thing 7 times? Well, you're going to get y to the 7th power, because this is actually equal to y to the 4th times y to the 3rd, which is y to the 7th. And you'll see that if you have this, you actually add the exponents together and get 4 plus 3 is 7. Well, here, we're going to leave all these in exponent form. And so 2 to the 4th times 2 to the 2nd would be 2 to the 6th. Don't worry about trying to simplify that on these exercises that are numbered, 8, 13, 19, or 32 here. All right. Now, a times a, that's the same as feet times feet over here. So if we have a times a, that's just going to be a squared. And this one would be 4 to the 1st power. Remember, if you don't see any number like 7, it's actually 7 to the 1st power. So if you see 4 just by itself, it's to the 1st. So this would be 4 to the 6th power. Because if you expand this out one more time, this would be 4 times 4 to the 5th would be 5 fours. Like that. And you can see you have a total of 6. So 4 to the 6th on that one. This would be, since we have the same base variable in this example, or it works with numbers, like you can see 2 and 2 becomes 2. X times x, x times x times x would be x to the 4 plus 3 plus 5 power. So you would just add these exponents together. Okay, 4 plus 3 plus 5 would be x to the 12th. Okay, so that's some kind of what makes the rest of this work kind of activity there. So let's look at the rest of this. There's a bunch more, so bear with me here. If we have to simplify exponential expressions like this, this is key to understanding the rest of this. So when we have this, we take the coefficients, the 5 and the 3, and we add them, or not add them, we multiply them together. 5 times 3 is 15, and then we put the y's together right after it. So it's going to be y to the power of 6, because when they look like this would be y times y times y. This would also be y times, I'll write it out once, and this would be 3y's over here, and you would have 6 total. So 15y to the 6th. Now, if you think you have the hang of this, pause it, try the rest of them. All right, this would be 5 times negative 4 would be negative 20, and we have y times y, which would be y squared. This one, 3 times, and by the way, you should always pay attention to how, if you're multiplying, how many negative signs you have. So I have 2 total, so my answer is going to be positive. So it's just 3 times 2 times 4, that's 24. And then what makes this problem interesting, and the reason I picked it, is we have 2 A's and a floating B here all by itself. So I got A, and then this B here. So it's going to be A to the 2nd, B. And that's how you would handle that. You just sort of smash them together like this. There's like invisible dots right there. Okay, so there's like dots that's there, but we don't ever write those. So it's just 24a squared b. That's how you would say that. Again, if you think you have it, pause it. This is the same type of thing. All right, so I have 2 negative signs again. That's going to be 6 times negative 3 times negative 3. That's going to be a positive. That would be 54, because that's what, 9 times 6, yeah. And then the argument is, do you do y squared x or xy squared? Well, when in doubt, put it in alphabetical order. So x, and then I have 2y, so it'd be y squared. Y squared. All right, moving along into some applications, and yes, geometry class is back. But first, some distributive law stuff. some distributive law. Here, I would have two unlike terms times another term out here. And when you do that, you have to do what we did on the other page full twice. So this is going to be 7x to the third times 2x squared. That's 14x to the, I ask you, what power? And it would be 5. And then 7x cubed times negative 2 would be minus 14x to the third. This is the same thing here, except you're going to distribute it this way. You still have two unlike terms. These are unlike terms. Unlike terms here. Because this is y squared and this is y. And you can't put those together. Let me get rid of that word. Okay. Now, so we take 9y squared times 3y squared. Well, that's going to be 27y to the what power? 4. And then negative, or 9y squared times negative 2y would be minus because we have one negative sign, 18 because it's 9 times 2, and then y to the power of 3 because it's y squared times y. That makes 3 y's. All right, now, two geometry problems. First, you got to find the area and simplify. All right, so if we're finding the area of a parallelogram, that is base times height. And this here could be the base, and this could be the height. So if we put this together, the area equals 5x to the fifth minus 4 times x to the fourth. I better go back to a little bit different color because this is just base times the height. Okay, base times height. And now when you do this problem, it's going to look just like this one up here. It's going to look just like 66 because you have to distribute this backwards like that. So that's going to be 5. And remember, this is like 1x to the fourth here. I'll leave that 1 there just for the heck of it. So this will be 5x to the ninth minus 4x to the fourth. So just reviewing of the distributive law on this slide here. Finally, the last one. I don't know if it's the hardest one. It's just one that I felt like I had to put in here. Find the perimeter and simplify. Well, if remember, perimeter's distance around. So this side here would be 4x to the fourth plus 5x to the third. And this side over here would be 2x to the fourth minus x to the third. So if you're adding all these up, let me show you a little trick. I will show you a little trick here. Instead of writing all of this out, which would take a lot of room here, if we just look at the first terms, because they all match, it's x to the fourth power terms. Those are my like terms leading off. If I add those up, how many do I have? Well, I have 4 plus 2 plus 4 plus 2. That's going to make 12 x to the fourth. So that's my blue. Now, let me get a different color like orange here. If I take the plus 5x to the third minus 1x, another plus 5x to the third, and another minus 1x, I am going to have a total of 10. That's 5 plus 5. 5 plus 5 is 10. Minus 1 minus another 1. So this is minus 1, and this is also minus 1. So I basically have 10 minus 2 total. So that's going to be plus 8x to the third. And we'll check that answer real quick, and that is correct. So there you go. If you need to go back and watch this again, do it. It makes you feel good. Talk to you later.